So much like last lesson, Year 9, what we're going to do today is stuff you already know, or really should know. Alright, and so I don't think it's going to take much recapping, so I'm going to quickly dash through the skills and let you get on with some questions. So we're looking at interior and exterior angles, so see if you can remember off the top of your head the rules for this. So just write them down what you think they are. Pause the video and do that. So, the interior angles, if you remember how we did this, so we did this as a bit of discovery kind of last year, I think. You think about this polygon here, so we've got a 1, 2, 3, we've got a hexagon here. We think, okay, look, I would split that into triangles, if you like, and each triangle has 180 degrees in it, so it would be 4 lots of 180 degrees. There are 6 sides. How do I know how many triangles that would split into? Well, I just do the number of sides, take off 2. Okay, so if I had a square, it's got 4 sides, take off 2, and I get 2 triangles that would split into. So the formula for the interior angles of a polygon is, it's the number of sides, take off 2, and I take the result of that, so that needs to be done first, times 180 degrees. That is a formula I'd imagine a lot of you will already remember. So, as an example, so for this one here, I've got the number of sides would be 6. I take off 2 times 180. So I get 4 times 180, which is 720 degrees. So just to put that in context, that means that if I added these angles all up, they would give me 720 degrees. So here's like a common basic question on this. I need to work out this missing angle Z. Well, first of all, I work out what all those angles must add up to. Well, there are 1, 2, 3, 4, 5, 6, 7 sides. It's a heptagon. So I'm going to do number of sides, take off 2. And times that by 180. So it's 5 lots of 180, which is 900 degrees. Then if I just add up these angles here, so if I add up the angles that I have, and I get 776, so if I do 900, take off 776, I get 124 degrees. So that is interior angles. For exterior angles, we have got something slightly different. If you remember, these don't actually, the exterior angles are not what you'd expect. You'd expect the exterior angles to be these here, but actually they're not. The exterior angles, if you pick a starting line and you carry it on, and you carry on the same route the whole way round, the exterior angles are these angles here. Okay, so similarly, if I do it the same on here, I can do it either direction actually, it doesn't really matter. So if I go around anti-clockwise on this one, alright, so carried that on. These angles here are the exterior ones, and quite often people get confused about what they are. So those are the exterior angles, and the interesting thing about this is these do not vary according to the size of the shape. You think they do, but they don't. So the rule is quite simply that the exterior angles of any polygon sum to 360 degrees. Okay, so they will always add up to 360 degrees. It doesn't matter how big the shape is, if it's a 100-sided shape or if it's a 3-sided shape. All of those, the exterior angles used in this way, they will add up to 360 degrees. It's a bit of an easier one to apply. As an example here, I have got a hexagon. It doesn't really matter what shape I've got, but I know those exterior angles all add up to 360 degrees. So if I add those ones together, I get that they are 310 degrees in total. So I just need to do the 360 degrees, subtract 310, and you work out that missing angle is 50 degrees. So here we've got a regular heptagon. So if you remember, regular means that all the sides are the same and all of the angles are the same as well. So let's look at the 2 cases here. First of all, let's look at the interior angles. So I've got 7 sides, so it's 7, take off 2, times 180, and then if you remember, so I want to know what the value of one interior angle is, so I'm going to do that to work out how many the angles add up to in total, and then just divide that by 7. So I get 900 divided by 7, which is roughly 128.57 degrees. It's an it's a recurring decimal, but we'll probably want to give it to like 2 decimal places or whatever the question gives. Okay, the exterior angle, well, all I need to do that is 360 divided by 7, because I'm splitting that 360 degrees equally between the 7 exterior angles. It will look something like this, and I get 51.43 degrees. Now, hopefully, without too much trouble, just have a look at those two values we worked out and work out the connection. Okay, hopefully we can just see quite easily that when I have these two are obviously going to add up to 180, because if I've got the interior angle here and the exterior angle here, those two things put together give me the 180 degrees. So if I need to get one from the other, and it's sometimes useful, you might be asked to find one thing, but it's actually easy to find the other thing, and you can use that to then work out the other. So as an example, here is a question. The interior angle of a regular polygon is 175 degrees. How many sides does the polygon have? So we've got two options here. We can either say, right, so the interior, how do I work out the interior angle of a regular polygon? Well, the formula, I'm just going to use n, is n minus 2 times 180, and then divide by the number of angles I have, and I am told that that equals 175 degrees. So that on the left is me working out the value of one interior angle of a regular polygon. So then I can just solve this like an equation. So I've got 180 n minus 2. I'm going to multiply both sides by n to get rid of that denominator. It's 175. So I've got 180n. I'm going to multiply out this bracket. Minus 360 equals 175. That should be an n there. 175n. Okay, let's collect them over to one side. So I'm going to take 175n away from both sides, and I get 5n minus 360 equals 0. Let's take that 360 over. So 5n equals 360. Divide both sides by 5, and I get that n is equal to 72 degrees. That's fine. That's okay. That's an absolutely fine route to do that. However, if I'd have used it for trying to find that out using exterior angles, well, I go, okay, so if the interior angle is 175, that means the exterior angle equals 5 degrees. 180 minus the 175, and then I can just do 360. I know those exterior angles have to add up to 360. Each one is 5 degrees. So I just do that and I get 72 degrees as well. Much quicker to do it that way. And sometimes when you get a question, just think, this is feeling quite complicated. It's only like kind of a 1-2 mark question. Think, is there an easier way to do it? Can I do it kind of by using the exterior angle as opposed to the interior angle? Okay, so if you'd like to now get on with the work, that'd be fantastic. Let me know on the Google Meet if you need any support. If you've never seen any of this before, then please please crop up and say, look, I didn't get any of that. I've never done this before. Can you help me out? And I can talk you through it a bit more on that Google Meet.